should start, but people can't find this room, so it's always complicated. And then it's always like 10 minutes up, but we will start a little earlier. Normally we start at 10 after, but we'll start now. That's Matt over there, Matt Espe. He's a plant scientist / our postdoc here at the DSI, so we're doing this together, but he's got a bad tongue, so I'll talk with him. Okay, but he'll chime in as we go along. So Pamela said that this is what regular expressions is, but it's not. Okay, we'll talk about, if you want a comprehensive introduction to regular expressions, that's great. Book. Okay, it's a very thick book. Okay, I teach this in 3.5 hours in a class, and yet this book is huge. And this is part of it. Regular expressions are weird, but we're kind of connecting it to both cleaning data, which we don't know of anyone who actually teaches how to clean data. There is no way to teach it. It's totally not context specific. That just can't be right. It has to actually be slightly more general. And there are some generalities. And one of the tricks to cleaning data, especially text data, and all data is text, even if it's all numbers, it starts off as text, so we can't fix it. One of the connections to this is regular expressions. And then reading data, which we'll come to at the end. It's just really, really useful to be able to sort of manipulate non-standard text into a form that can be read in a standard way. We all love tables, but a lot of data don't come as tables. I'm going to show you some simple examples, even where we have tables, but they're not quite tables. There's an extra little piece. So regular expressions is the unifying theme. We'll talk about regular expressions, and we'll show you some of them. We'll show them to you. Okay, they're very. It's a very small little language. There's nothing like as big as this book. Okay, and then there's dialects, and it goes on and on and on. But the most important thing is to figure out when you should use them, which is never, okay? Or always, somewhere in between. Okay? There's a nice phrase that if you have a problem and regular expressions is the solution, you have two problems. Okay, they're basically hideous things. Okay, but they're so powerful and they're so useful and so convenient that they're really, really useful to have in your arsenal of tools. Okay, I use them every day. I use them in Shell. I use them in Python. I use them in R. I use them in C and C++. I use them in every language that I write in, and yet I try to stay away from them. They're never the right answer. There's always a better answer. So, for example, and just to get this out of the way, if you're trying to read XML or HTML documents, do not use regular expressions.
Or JSON.
Okay, if you're trying to read JSON, do not use regular expressions. You can, but your life is going to be miserable. Okay, and there's much better tools. If you're trying to do natural language processing to find out nouns and verbs and sentences, even if you're just trying to break sentences, don't use regular expressions. There are tools for this. Okay, if you're trying to do all three of those on a desert island, okay, for some reason, okay, regular expression is a fabulous tool because you can do all of these. And anything you want to do, you can do with regular expression. It's just annoying, but there's a better solution for any single thing. But that means you've got to learn lots of things. Whereas if you just learn a few of the regular expression tricks, you're good to go. So the analogy is basically this is the Swiss Army knife. Okay, of tools, but there's a better tool for those of you who play with Swiss Army knives. You ever tried to saw with a Swiss Army knife? Saw. Okay, so take a nice 2x4. Oh, this is going to be painful. Okay, so it's never the right tool. You go and get a saw. But if all you've got, or if you don't know how to find a saw or whatever it is, you're better off because you can do something. And regular expressions are exactly that. And they're really, really useful, but they really are hideous. I don't actually have it here. I should pull one up. I normally start with regular expressions, which is I show one regular expression, which is so hideous that you basically go, I'm out of here. Okay, they are, as I like to point out, they are like hieroglyphics. Okay, so when people come down in 60 years' time, 100 years' time, look at what we did on the computer, they will just laugh. And so you actually did that, and yet they're so powerful. Okay, so they to be avoided and yet but used every day. So that's what we're talking about. Okay, reading regular tabular data in R, even that can go wrong because you sometimes have to fix it first. You know, we can talk about examples of that where there's missing quote characters or stuff. Sometimes reading regular data is actually really tricky in R. So some background stuff that we want to talk about. As I say, there's a bunch of books. There's so many tutorials on regular expression because they're involved in every language and they're available in every language. There's so much material. You don't need me or Matt to actually explain the syntax and the detail. We will do a little bit of that. It's much more about the process. Again, how many of you have ever taken a class where they actually spent more than 20 minutes talking about cleaning data? You put your hand up. Okay. So, anyone? And yet, so how much time do you spend cleaning data?
80%.
80%. Okay, it's between 70 and 90. Okay, so 80 is the perfect number. Because this is the one statistic everyone agrees on. It's that we spend 70 to 80 to 90% of our time munging data, cleaning, transforming, exploring, fixing. And then we do a little bit of modeling and stuff like that. So it's huge, and these things are, but there is a process behind this, and also Matt and I got into a discussion yesterday about actually what are the right things to do. Issues of writing software versus writing scripts, but there's also an issue of actually cleaning data and actually thinking about the bigger picture. Okay, and it's not obvious actually. You need to be reminded about you need to do this properly, because as humans we always do it the wrong way around, or we take shortcuts. Okay, one of the important things is this. Again, I like to be mean. Okay, so the difference between statistics and math is huge, because a lot of statisticians, a lot of mathematicians cannot handle ambiguity. Okay, and if you can't handle ambiguity, you cannot clean data. Okay, because sometimes it's just not clear what the answer should be. You've just got to evaluate whether or not this truly is a value that's 67, or really should it be 76? Okay, is it a transposition or whatever? Okay, you actually need to do this, so you have to do this, but you also need to be very, very careful about that ambiguity. You can completely transform your data and be 100% certain you're right and be completely wrong. Okay, so that means you basically need to ask the owner and the collector of the data, what the heck was going on? Do they have more knowledge than you do? So there's a huge amount of discussion and interaction and communication to be done. And by the way, so how many of you are undergraduate students? No, okay, good. Yeah, okay, but this should be packed with undergraduate students, because when they get a job as a data scientist or a data analyst, this is what they're doing, is cleaning data. Okay, and they're not necessarily prepared for it, but this is actually a very useful skill to actually be able to. People will hire people who can clean data effectively, and then graduate on to that. Okay, the other thing is this. I mean, these are all eat your vegetables, do the right thing. Okay, except for cleaning matters. Okay, and you only find this out afterwards. Okay, you better explicitly record any cleaning that you do. Okay, one of the ways to record it is to put it in code, so that we can at least read the code and be reproducible. And reproducibility is huge. But you better, if you go and sort of say that missing value should be the mean of all the columns. Now all of a sudden, so you have two observations that have no missing values, and you've got 100,000 that have missing values. Okay, for that column. So you take the mean of those two numbers and then you replicate it. Okay, your statistics are going to be wonderful. Okay, they're all going to be made up. Okay, so it's clear that you have to change your degrees of freedom. So you better, at the very least, you need to actually be able to explicitly record that this was imputed. Okay, that we actually made this one up based on the average, and how we did it, and whether it was the mean of everything or the mean of a particular subgroup or so forth. But you better just record this. For yourself is really one thing, and of course to others, but actually you are the most important person, because when you come back and look at this stuff and say, why did I do that? It's got to be important. Okay, and also you need to be able to come back and actually review your decisions. Cleaning, you go around, you clean, you do your analysis, you go back and check to see whether the decisions you made when cleaning actually influence your analysis. So sensitivity analysis is actually important, and you should be willing to actually sort of change your decisions about that. Okay,
and I would just say we're always overly optimistic about how much we'll remember or our cognitive state down the road. So always err on the side of recording too much, because I know I'm always like, oh, I'll know exactly what I'm doing. And then 6 months later, I'm like, I have no idea what I was doing. So just know that about, because it happens over and over and over again.
So the other thing is this, we've got moved, I'll raise some, I'll show them some questions about this, is if you're actually going to actually clean data, you really, there's no way you can teach this. You've got to think about what could possibly have gone wrong. There are a couple of generic things, but it's uncanny how creative we are going wrong. There's a nice example where people actually collected stuff in the field and wrote it down on clipboards. Wind comes along, blows everything, and the order of the page is now completely changed. Okay, and now you actually haven't recorded the actual order which the data were collected. There's all sorts of interesting stuff, even when it's completely electronic. One of my favorite examples that I ran into is I was in a factory where I used to work, and we found this massive anomaly. So it's like, that's your problem. And they said, no. After about 15 minutes, they said, no, that's when we start recording a different variable in the same column. Good to know. Okay, so there's just all sorts of weird things, even when it's completely and utterly sort of non-human involved. Okay, another big thing is this. We'll see as an example. This is check your data using auxiliary data. Okay, you have to be creative about how can I verify this data by using other data. And again, this is partially a statistical argument. If I can find data that are similar, but also just we're going to look at house price sales. We have a recording of them, but we just look it up on the web for that one house. I don't want to do it for 400,000 houses, but I can do it. I could if I wanted, but I can go and actually check individual things. And this, we'll reinforce this over and over again. Okay, this is really part of the life cycle. One of the big issues is, okay, we'll come back to this in a second. Is this is from the USGS. Okay, you plan, you should do your experimental design, you think about what data are available, you go and get it. But then you basically, this is beautiful. This is a nice linear progression. How many of you have ever followed this? Okay. It just doesn't work because this analyze. We know that the analyze is incredibly iterative. We analyze, we look at residuals, we go back and we change our model. Everyone knows that kind of idea. This notion of preserving and publishing assumes that it's actually worth preserving and publishing in the current form. Okay, but a huge amount of it is actually go back and reacquiring data. But then what's really aggravating and really useful is while we're cleaning the data as statisticians, let's say, or data scientists, people are continuing to collect data. We want more data, so why do we cut ourselves off from this? So I think they're going to stand by, let's say if they have an Excel spreadsheet, they're going to continue to add to the Excel spreadsheet. If we can't come back and actually put our changes back into the Excel spreadsheet, or actually take that updated Excel spreadsheet and make our changes live, okay, for our analysis, we've now got 2 separate projects going on that we never meet. Okay, so we're basically being marooned, okay, are completely sort of separated. We're going to go down 2 different paths. So it's very, very important to think about who you're collaborating with. And it might be you again. Literally 6 months later, you come back and actually recollect data. So you need to be able to reproduce this and actually fit it into the complete life cycle of the data. Most people, especially though, this is true, very much true of statisticians and computer scientists, are given data and they kind of think it's over. And it's not. Okay, because I've seen this often enough. They give you data, you work on it for a couple of days, and then they go, oh, by the way, I just found out with a mistake. And they give you the new data. Okay, it's exactly the same number of rows, but you say, look, I just cleaned the whole thing. And you go, let's start all over again. Okay, and this is why we want to have code that can be reproduced, that can actually make the changes. And that's not obvious how you do that. Okay, because if people change the row numbers, you can't go back and just use the row numbers. You actually got to go find that observation to move around. So this is a little bit tricky. But the point is, you really have to think about: are you dealing with a fixed, locked, static CSV file? Are you dealing with that is exported from an Excel spreadsheet live that it could update? Okay, does it come from a Google spreadsheet? Should I write the changes back into those files and then share them with the other collaborators? This is kind of important. Okay. So it's highly sequential, iterative. This beautiful linear diagram just doesn't get the actual nature of how we're actually doing things. Okay, and again, one of the things that Matt and I were doing is we basically put these slides together for reference. We're going to just go into sort of live coding to put our exploration and put up, which is very irritating as you follow along. We've actually written a bunch of narrative documents that actually wander through and say, this is why we're doing it, this is how we're doing it. So these are all available on the webpage or the Git repository. So this basically just gets to this whole notion of how do we actually fit into the life cycle, and how when people are messing around with Excel, Google Sheet. Many of you have come across OpenRefine. Okay, so not too many, but some of you have. Okay, OpenRefine is a wonderful tool that does a lot of cleaning. Okay, and it's really it's fabulously useful. You can do it all in R2, but why reinvent the wheel? It actually tries to capture some of the general concepts of cleaning. That's great. Again, mostly it's interactive. So you do it, you make decisions. You're not recording those decisions, you're recording the changes, which is a problem. Okay. And then if somebody actually says, I gave you the wrong CSV file, you got to start all over again. Okay. There are mechanisms to actually do this in a reproducible way. And that's kind of what we're actually what we're trying to do. I put it up here. For those of you, this is the Git repository with the documents that we wrote to actually go through some case studies. There's also some data there, so if you want to follow along, be our guest. The slides are there, and we'll continue to update these as we sort of find errors today, as we're wandering through things that I haven't actually finished. So I say, nobody really spends a lot of time talking about this. Somehow it's assumed you all know about this. The life cycle is really, really important. The idea of reproducibility is really critical, and it's slightly context specific. If you're lucky enough that the data really are fixed and done, you don't need to worry about upstream changes, but you probably want to. You certainly want to be thinking about upstream changes for yourself. Okay, a lot of what we end up doing. This program defensively. Okay, a lot of what we actually do is we actually take a CSV file, we read it, we start making changes to it, and then we realize that we have completely and utterly corrupted our data set. Okay, and what we actually need to do is go back and start all over again. So it's so easy to sort of say, find all the observations that have age being less than 10. Okay, and change those to be NNA or something like that. And then all of a sudden you find out there's a typo or there's a mistake, a logical mistake. Especially as those conditions get more and more complex, and all of a sudden you've wiped out every single observation in that column or whatever, or you've actually removed some rows that shouldn't have been removed. You need to be able to go back and start all over again. That's kind of where you're writing a script that you can run again, as opposed to that you're interactively doing. This is extremely important. Okay. Okay, so you actually are kind of writing software, and especially, as I say, one of the examples of the seal that are in these narrative documents. If you identify an observation to remove or fix by its row number, and all of a sudden you remove a row above it, you're now starting to corrupt data. Okay, so there's a lot of assumptions that you're making interactively that you should not be making when you want to go back and replay this code or this whole entire process. I don't want to yell when there's any questions on it. Okay? Yeah.
So how do you differentiate software versus script?
It's a continuum. it's a continuum. So I think of software, and so he wrote this. So. Yeah. So you're aiming to write sort of along the continuum. Software I think of as other people can use your code. Right? So you can give it and you can go away, and people can use it, and it's highly parameterizable through inputs to arguments to functions, and that's great. Scripts it does one thing. Okay, you run it and it will produce an answer. Okay, and that's fine. What we're getting at in between here is it's still a script that does one thing. Sometimes scripts can take different arguments, like different input files. Okay, so that now it can be applied to two different files and do the same thing. But the critical thing about where this becomes script and merging, leaning towards software is I can do it again and get the same answer. That's the reproducibility argument. Okay, that basically that I have a CSV file and I run the script and it cleans it, and then I go and
augment that script, or I run it, or I simply run it again on the same CSV file, and I get the same answer. Okay, but if it writes out that CSV file, okay, so if I have CSV file here, run a script on it, and I write this, and I overwrite the original CSV file, running that script again will not work because I've removed rows or cleaned up conditions, unless that script is quite defensive and actually checks the conditions before it starts removing things. That make sense? Happy? But it doesn't matter whether it's software or not, but they're different. But see, you're getting away from, you know, it's almost like you're getting away from interactive, where you're just making commands that where you're taking advantage of it's row number 7. And then later on, it's not. It's row number 6, and your code is now completely broken. Okay, so it's a little bit more robust. Everyone happy? So he actually has some. So, yeah. Okay, so okay, regular expressions. Okay, there's like everything these days in R. There's there's base R, and there's now we're up to almost 12,000. We're over 12,000 available packages. So people have added new functionality for regular expressions, string manipulation, and so forth. And these are the built-in ones. You can do everything with these. These are the fundamental units. There's two functions we use a lot: grep and grepl. This find. Both of these are, you look for a pattern. What's a pattern? It's in text. We're looking in text for a pattern. Okay, it might be look for the word dog. Okay, it might be look for the numbers 1, 2, 3 in a row. Okay, and maybe some really complicated things like find 3 numbers in a row followed by the name of the month, followed by 2 digits or 4 digits making a year, or they have to start with 19 or 20. Okay, we can do all of that through regular expressions. Okay, and if you think about how you would write that code yourself, you should say, I want to learn regular expressions, because that's hideously ugly code. Okay, it's very complicated. These things are super fast and super general. Okay, grep will find, it takes a vector of strings and will find which elements match the pattern, or in which elements the pattern is matched. Okay, and grepl will actually turn back. So grep will give me the indices, the positions where they match. Grepl will return whether this element matched or not, true or false. So we'll get back trues or falses for every element. They're just one and the same function, essentially. Okay, this function gregexpr and its sister regexpr. Okay, they actually find where in the string the text matches. It actually gives you the start and end position, which means you can actually say, yeah, it matched, but I have no idea where. Did it match the whole thing or just the first 2 characters or what? gregexpr says I can actually find out exactly where the matches are. The G. Well, the grep is actually this for down here. For some reason, when we write these slides, they drift off the bottom. Some of you who know shell commands, grep is a shell command. You go like, which one am I using? Okay, this is an R function. This is a shell command. They're similar, very, very similar. This grew up in Bell Labs and sort of this global replace operation. Okay, this is very similar. This G here is slightly different from the G here. This one does it. This one will match multiple matches within a single element. G is global, so it actually does multiple matches. This is just finding one match, okay, in each element. And then these guys say go find this. Okay, this side says go find the start and end for the match, and if you don't find a match, give me -1. Clearly can't be a match. This guy actually extracts the matches using the results from these. Okay, it's a handy way of actually pulling out the matches. We have another thing that we do a lot of is substitution. So we take a piece of text, okay, and I say, yes, but I want to change that piece of text by finding the pattern I want and actually replacing it with another pattern, another piece of text. Okay, that's just a substitution. That's what the sub stands for. Everyone with me? If you actually understand, if you know these functions, there's a whole lot of other ones in the string I package and the string R package, but they all do this. They all sit on top of important fundamentals like this. Okay, so we can do really funky things like so saying, go find this pattern, take a subset of it and actually replace it with take that bit out, dynamically find out what's in there, and stick it in here and actually augment it in different ways. And we'll see examples. So it's very rich. We do an awful lot of splitting of strings. So often we split a string based on a comma or a semicolon. We can do that, but we can also say, find 4 digits in a row followed by this and split pairs. That's so it's a dynamic split. It's an actual pattern that we're splitting on, which is very, very helpful. Okay, so this takes this takes one vector and returns a list with as many elements as there are in the vector. Okay, with the elements, with the sub-elements broken up into a character vector. So it's kind of a little weird, and I'll just mention it now because it's important. So you start off with a character vector. This is a character vector. You put this into stir split. Okay, and you split on something, let's say semicolon. And then this will actually give me back a character vector like this for the first element, another character element for the second element, and so forth. Okay, so if there's n elements here, we'll have n elements here. But of course, there may be a different number of sub-elements in each of these. So we have to treat it as a ragged array. So this is a list. Okay, and that can really, when you pass in a vector of length 1 here, you still get like a list with one element, which is the vector, and you go, oh, just give me the darn thing. I always forget. So, coupled with the fact is, these guys here, just for fun, these guys take the pattern you're looking for and the vector you're looking in. This guy takes the vector you're looking in and the pattern you want to split. They're backwards. Okay, for good reason. Everyone happy? No questions?
So one thing, when we were putting this together, often people will say, well, you should use regex, just use them. We thought it would be good to show how you can clean without them, and then hopefully you'll start seeing like, oh, we really need them.
Good point.
So one thing, you can actually do a lot of cleaning without them, and like Duncan said at the beginning, don't try to make a regex do every darn thing that you're trying to do in your cleaning, because one, your code will be a mess, and two, you'll be a mess because it'll make you crazy.
So Paul and when he says regex, that's a regular expression. We just use the term regex. Okay. So I'm following these slides, and this is problems. We say this is about cleaning. As Matt points out, we can clean without regular expressions, but good to know about them. But we'll use these functions. But the important thing is this is just a subset of functions that you actually need to do really an awful lot of manipulation. We can talk about these two later on. Okay. Clean. Okay. So if you go to that Git repository, what you will find is a bunch of right here. That's over here. You should find this sort of stuff. So low down on the slides. Okay, so there are slides down here. They're all looking in markdown of various different forms. We're gonna look at this guy over here. And there's some data lying around here as well. So if you want to follow along, be my guest. Okay, this comes from this house price sales that Henry Whitman pulled together and a few other people for an article they were writing. It's just do this. I say we've got way too much to cover and too little to cover, depending on what we do. So this is the narrative form. I suspect the best thing to do is to actually read this, okay, rather than actually read this book or some tutorials, but actually figure out how to use them, when to use them, why and what the process is a little bit more interesting than just tutorials and sort of dry syntax reference pages. These data that we actually have are the following. They should be from the early 2000s. We're going to have to look at the data and see where they are. That's kind of a circular problem. If we look at the data and they're wrong, we actually have to fix them. So we're going to figure things out. Okay, so it's this house price blues paper. Okay, the data were essentially these are the data that we actually get. We have so they're very easy to understand. Okay, that's the beautiful thing about them. Everyone has an opinion about this or some understanding of. Okay, we basically get the name of the county in which the house. So these are about house price sales.
that are recorded, that are actually registered with the county. Okay, we got a county name, the city name, the zip code, street number, and name, the price that the house was sold for, the number of bedrooms. These are kind of now starts getting a little bit cryptic as to what these are. Bedrooms is the number of bedrooms. BSQFT is building size square foot, okay, in square feet. LSQFT is the lot size square foot, okay, so how big the parcel of land is. The year, this one confuses me every time. The year is not when the house was sold, it's the year the house was built, okay? The date is when the house was sold, okay? The long and the latitude, we don't get that. For some reason, they do not record the longitude and latitude of the house when they sell it, okay? That seems perfectly reasonable to me. What happens is we actually somebody took the street address and the city name and the zip code, and they went and geolocated it off of a massive database, and then they got back the latitude and longitude. Okay, so these are augmented data. These are kind of derived data, which basically means that these could be totally wrong if some of these are wrong. Okay, and now we're sort of propagating errors and then asserting truth. Why is this thing in the middle of the ocean? Well, okay, and then there's these variables which we just don't care about. Okay, that tells us about the geolocation. So I'll tell you a little bit more. I can't remember that. So the data are something. So when you buy a house, the deed is transferred. Okay, I'm making this stuff up. Okay, I did my house, but I can't remember that. I'll check for how much. So somebody actually takes all the details and actually gets recorded for legal reasons and also for financial reasons. So you pay property tax. So you actually have to record how much the house was sold for us. So there's somebody, everyone signs a million papers, and somebody then actually submits documents, okay, to the county, and then the county people take this and then type it in. You'd think this would all be done digitally. There must be an app for this by now, okay? But maybe not. There's certainly different interfaces. Each county, I think, has different approaches to this stuff. Okay, then, so I'm just trying to, the point of this is I'm trying to figure out where things can go wrong. Okay, then, let's assume these are all beautifully entered by all the people working in the county. Then, they were actually extracted by SFGate. Okay, the actual newspaper analysis, okay? Okay, they were collected and pulled out of all these different counties. Somebody had to aggregate these. Okay, then somebody scraped them from SFGate's web form. Okay, then somebody took the HTML from scraping and actually put them into this thing called debian control format, DCF, with name, colon, value pairs, and they assemble them by year. Okay, or actually by week, should I say. Year, month, week, okay, all the house sales. Okay, so there's code involved here, there's code involved here, there's code involved here by different people. How many of you have ever written a piece of code that had no bugs? Okay, so there's a bug in this code, okay? Okay, then we read them back into R, and then we arranged them into a data frame. They didn't start with a data frame. Okay, and then we wrote them to a CSV file, and then somebody shipped the CSV file, and I got my calls on it, and then I changed it, and then I forgot how I changed it, I didn't record anything, so I have no idea what's in this file anymore. Okay, so just think about what can possibly go wrong. Okay, and I'm serious, it's not about, oh, think about how many things can go wrong, think about what can go wrong, because you can't clean the data unless you can anticipate what could possibly have gone wrong. And if you can't, then there's a couple of general approaches to this stuff. This, how many of you do this when you load a data set? Even if you wrote the data set, how many of you do this as just a matter of course? Okay, not enough. Okay, just do this. I read a data set, I just say, what's the type of it? And if it says data frame, it always says data frame, okay? Because it says read.table, but it doesn't read.csv, read.table, okay? But then I just say, okay, well, hang on a second. Tell me how many columns there are, how many rows there are. Why are there no rows? Okay, this is, okay, now clearly there's a problem here, and this is my mistake, or whatever it is. I'm reading the wrong CSV file. The one I downloaded didn't actually download, and it still got 0 bytes in it. That's why has it only got 3 rows when it should have hundreds and thousands? Because it didn't download, and I closed my computer, and so forth, okay? The next thing is quickly check what the class of each column is, because this is going to be a big one. Year should be an integer. It's the number, it's the date in which the house was built. If it ain't an integer, there's something wrong. County should be a string, okay? And I should look at the levels of this, okay? But I should look at price. Price should be a value, okay? And if it's not, there's some problems. So immediately you can diagnose some major problems just by actually looking at the type of the column, okay? And then look at the column names. And if the column names don't, it is quite conceivable, by the way, you actually have one file with a totally different set of data, okay? That somehow you managed to actually mess up the name of the file and the contents of the data. So you're now looking at a file that has some genetic data, and I'm supposed to be looking at some house prices. It's still a CSV file, but you didn't actually, you don't know this until you look. There are people who actually think that you can do data analysis without actually looking at the data and actually just sort of say, SAS, proc, do analyze my data and submit the paper, okay? You actually have to look every single step of the way, okay? So what are we doing? The next thing we do is this, okay? And again, how many of you do this? Leader in truth, I religiously do this. The next thing you do is just summarize the stupid thing for me. Okay, and summary is supposed to be, it will actually, on the data frame, it will actually do this, okay? Okay, it will basically give you a summary of each of the columns. Okay, and again, do I see any weirdness? Okay, this is all, by the way, we all go, oh, this is totally obvious, and it is, so far I'm talking totally obvious stuff. And yet, why does cleaning take 80% of the time? Because it ain't obvious, okay? It's only obvious after we've done it, okay? But then again, we're trying to be general, okay? But basically, we've got all these counties. Anyone notice anything? Any anomalies? So basically, it's not going to print every single county, okay? Well, it will. There's only 9 counties in the Bay Area. This is all Bay Area data, depending on what your definition of Bay Area is, okay? Which is an interesting. We'll include that one, but not this one, okay? So by design, summary tries to aggregate, because this one, the cities, how many cities are there in all these counties? There's probably, I don't know, 100, 150 cities. We don't want to see all of them because there's just too much information. So what summary does is actually just gives you the counts of the top cities, and then just says everything else is in other. We're going to have to go back and look at this. But this guy, zip code, okay, hang on a second. Zip codes, you should not be adding zip codes. You should not be averaging zip codes, okay? But it is because they come in, because we didn't tell us that zip codes are factors, that they're really they're identifiers. It read it as a sequence of integers and then tries to actually summarize that. But that's fine. That's not too bad, okay? There's, we're in reasonably good shape. We've got 28 missing values. That's, I mean, how big is this? It's about, I think there's 400,000 houses in here. 28 missing values, not too bad, okay? Do we care? Probably not, okay? Maybe I do, okay? That's the other big thing is, I'm not gonna clean this data if I don't care about zip code, okay? I may care about zip code. For the purpose of this, I may just be interested in price versus building square foot, or being able to predict the price, irrespective of zip code, if I don't think zip code is important. But if I want to connect zip code to good schools, bad schools, median household price, median household income, should I say, I may need to bring in auxiliary data, in which case the zip code better be correct. I better not be bringing in the wrong values. Okay, everyone happy? Anyone see?
I might just add a little bit to that is, it's really common that people will just set out to clean every single column and end up discarding data that they actually care about that has a missing value or a strange value in some weird column that maybe was added by someone, you know. It's really, really common to watch people throw out a ton of good data because it's like, oh, what is it? Geolocation is blank.
And we don't care about geolocation, so why would we throw it out? We see this all the time, especially in undergraduate classes where there's a function in R called na.omit and complete.cases. Stay away from them for the moment. Okay, they're useful for purposes. But what people do is they say, this one's got a missing value in this column, this one's got a missing value in this column, this one's got a missing value in this other column. I'll get rid of every observation that has any missing value, even if I'm never going to use it. Or even if I'm going to use it for one particular task, I will just decimate my data set for no good reason. If I want a plot of price versus bedroom, why do I throw away the observations which have geolocation with a missing value? It's just pointless. So so people seem very eager to throw away missing values. I mean, entire rows with missing values where you're much better off throwing them away when you're about to use them. Okay, only when you're about to use them. I don't know why people are so willing. They take stat classes where they learn that the bigger the size of the data, the better, and then they throw it all away on a moment's notice. Just like, you can't remember it. Okay? Anyone notice any problems with this? Ideally, summary will tell you if you got problems or not. Anyone see any problems? We got to look at the actual values here because it can't show everything. So we're going to have to look at these.
The maximum number of bedrooms.
What has to be?
Maximum square feet.
Also year.
A year.
I don't think they were being built in 38 and 94.
Just wait. So clearly, now we got problems, okay? And we're looking at, so hopefully what you know is we're looking at multivariate data. We've got 14 columns here, okay? We're looking for anomalies across in observations that occur in any of the variables or maybe two of the variables, okay? And oftentimes what you're going to find in some of these data, one column got moved, okay? So I'm going to guess that that's the price, which is over here. So somehow this got pushed over one column, and then we need to fix it. That possibly means that the other entries on that row also got pushed over. Actually, it turns out that didn't happen very often. It's like, oh God, who did this? I mean, it's just uncanny how this actually happened, but that's clearly anomalous. We've also got 66,000 missing values. Okay, maybe not. Okay, this is the. We've also got, you've got the building square foot here. This is ridiculously high. By the way, how many we got this guy here? Anything else that you see? So these are kind of weird. Anything else anyone sees? Yep.
Longitude.
What about?
All right, so I'm swimming.
So there's a whole lot of missing values. Okay, that's because the geolocation couldn't determine from the street address where the house was. Okay, and sometimes they can guess from the zip code, but not from the local specificity, but it will do something. Okay, but these are minus 121 to 123. Okay, that's okay. The latitude is 36 to 38. Okay, you know exactly how we record this. These actually seem fine. How would you check to see whether they're okay?
Pop it in Google Maps.
Pop it in Google Maps. Yep. And just actually get the rectangle for this, you know, just take the range here, or just plot them. See do they look, you know, do they actually look, you know, or you can pop them on a map and just sort of get a vague sense of are they about right. These don't look too bad, but they could be totally wrong. This could be in Venezuela. Okay, in which case it's like they're all off by a whole amount. Okay, but they all look perfectly fine until you actually know where the area is. Okay, so they look, again, if you take this approach, like, oh, those look fine, they look like a normal distribution. Okay, you know, they still may be incorrect. They may look okay, but be wrong for the actual observations. And it could actually be that they're all messed up. Every single row should be with another row in these variables. That's fine. Anything else? So we do actually have to take a look at these guys here, and because we can't see enough detail. Okay. Yeah. One other thing that I like, and this is when Matt and I started looking at cleaning this data, going through the steps involved. We looked at these guys. 4 missing values. Okay. And 4 missing values. That's too much of a coincidence. And I can deal with 4. Okay, 28 is testing my patience. Okay, 66,000 missing values is just I'm not going there by eye. Okay, but I will go through 4. This actually brings up a point. It's somewhat important general point. Let's try to fix those missing values, those 4, because when we start looking at other rows and other variables, we're going to keep getting missing values, and they're going to keep showing up potentially in these other rows. So once we can fix a row, it's unlikely to come back as a problem later on when we start cleaning other variables. So this tells us we've got 4 rows that have problems in date and price. If we fix those, they may not come back to bite us later on, in which case we'll be looking at less data. Okay, so is that clear? Am I getting it? So basically try to actually go for the low-lying fruit, easy fixes, fix them so they don't come back and make and sort of just add to the noise. Okay, so we can go through and do this, okay? So here, hopefully you all know how to do this. Again, this is yell and ask questions you got. Is.NA is just tells me truths and falses. So this is basically, I'm saying, show me the rows which have either price being missing or the date being missing. There's 4 NAs in price, 4 NAs in date, and lo and behold, we get 4 rows, which basically means they're missing in both. Okay, this could come back to 8 rows, in which case date is missing, but not price, and price is missing and not date. But it turns out that they're both missing together. Anyone notice anything?
Shifted
What shifted?
data. So the price, it looks like price is over a column.
That looks over.
Yeah.
But if that was the case, then wouldn't longitude be moved over too? Should be. So this does look like it's shifted over. How would you check to see if that makes sense?
I'll probably go check Zillow.
Okay, go check Zillow. Okay.
Second opinion.
This is going getting auxiliary data. Okay, this is what you do. You have to be entrepreneurial. And the other thing is you go and mail Hadley. Okay, the person who collected this data, and Hadley says, I didn't do it. Okay, Hadley checks his code, says it wasn't my fault, it seems like it was SF-Gate. So then you ask SF-Gate, and SF-Gate says, no, this actually comes from Alameda County, go and ask the Alameda County registrar. Okay, and then you go back, and that's a good thing because the registrar fixes it. Okay, so it doesn't come down with the number of bedrooms for this ridiculous house. Okay, so that's fine. So do go back and talk to people. Okay, but that may take a long time. So just actually checking on Zillow. Another way to fix this when Zillow's not around, in other words, when the data is not searchable, just take a look at all the other prices and see if this makes sense. Look at all the ones in Alameda County. Look at all the ones in Alameda County that have the same number of bedrooms, not bedrooms, because that's the deal. Okay, that have the same building square foot. We're kind of at our own here. Okay, we could look up the street address. So Zillow's not going to get us a good answer here because the street is wrong too. It's just 246 Fremont. Okay, I kid you not. This wonderful University of California sent me a check once to Duncan Temple-Lang, Ireland. And amazingly, I am the only Duncan Temple-Lang, not only in Ireland, but in the world. So it actually did make its way back. But this is not enough. So we're actually kind of stuck here with Zillow. Even Zillow, but we could look at Fremont. It's 1.4 million about right. Seems cheap. Bay Area. must be a tent or something. This is the scary thing about this data. This is 12 years old. But yeah, this data, this second observation is all NAs except for what? The county is a year. This is totally dead. This is just broken. Let's get rid of this. If we get rid of this, we just then we could go back and run the summary to see, because this county name is now, we didn't get to see all the county names because there was only 2 of these that actually had the year, but they were included in here as being the name of a county, which if we'd seen the whole thing, we would have gone, that doesn't look like a county like that. Okay, so we can fix this, okay? Anyone else notice anything else odd about this? Yeah?
It looks like it's really just 2 observations rather than 4.
Where?
Because the way that they're right next to each other.
Oh, this is just the way it prints.
Oh,
Oh no,
The wraparound?
you mean the rows are contiguous?
Yeah,
Okay.
yeah, it
So-
looks like we just got the data from one observation sort of just got split into 2 rows.
Yeah.
It's like kind of what it looks to me.
Really?
It's 2 pairs.
Because the first row is missing the day.
So the data that's missing from the first row is actually in the second row.
Okay, so it could be this. Notice that they are contiguous. And this is weird. So that's very suspicious. Okay, so there's a lot of information. These are not variables. These are just the order in which they appear in the CSV file. which is somehow related. So maybe we can actually piece this together, in which case, how did this actually happen? You wouldn't, if anyone actually goes and figures out how this actually happened, whereabouts in this provenance of all the different people who were involved in this, it's a little tricky, okay? But maybe we can fix this. So it's not even that we're actually trying to fix one row. We may actually try to combine two rows. Oh God, this is getting complicated, okay? So it's mess. It's a mess. Highly context specific because it's all the code that went through here to actually break things. Okay. So the thing to do here is to actually do what? Okay. So we can go through and we can fix this. Okay. Okay. One of the things to do is this. We just go back in and we sort of move the bedroom over to price. Then we set the bedroom to NA. Okay. And then we do this and we do the following. Is this a good idea? No, I'm going to say no. It's not tough to say. Okay, this is perfect code. It will fix this. If I run this in R and I go on, okay, then I'll fix the county names as well. I might as well drop the other two, right? And we can fix up the rows. We can combine the rows or whatever it is. Again, we've got to decide: are these really the same row? Okay. Or should I just delete this row and delete this row and delete this row and move on? Okay, that this is the ambiguity. Okay, does it matter? 2 out of 400,000, I don't really care. Okay, and I've got no information here. But depending on what the constraints are, you have to decide what to do. But what if we actually remove this row? So we remove that middle row, 37087. Okay, then this one would actually move up. Wouldn't be a problem because I put quotes around it. This is a weird thing. Without the quotes, it will matter. With the quotes, it won't matter. But it will matter if I write the CSV file back out again, because then the row numbers will not be correct the next time around. So what I really need to do is I need to actually be able to identify the rows, the condition by which I identified these rows and why I want to throw them out. We just found them by looking at the price and the data and date being missing. But we actually found something richer, which is, let's assume that these are actually 4 separate rows, that in 2 of them, all of the variables were missing, except for the county, we don't care about. Or another way of finding those 2 rows was that the county had the stupid name, which was actually started with a year. Okay, so that would be a much better thing to actually write down. Okay, this is actually more general. I may find more observations which are anomalous by actually looking for generalizing my criteria. Okay, so here's a quick little thing. This is actually, if you want something general, this is it. Okay, you should turn this into a function. Okay, here's the names of the variables I say. You have to have every single one of these. Okay, so you loop through all of the columns and you check which ones are missing or empty, all the values, okay? And then you basically collapse them all together. How many of you know about the reduce function? Okay, look at it. No, I know, that's why I like to introduce something that people haven't seen before. This is a simple little function. What this ends up with is one logical vector that says true or false, okay, for each element, for each row, and it says it's true if you're missing each of these values in these variables, and it's false if any of them are available. So now we can actually just go through and throw out those guys. That will catch our two rows, so we can drop those guys.
So one thing I would say is that kind of the important takeaway here is that we're addressing not the actual instance of what the data look like, but the actual pattern or condition. So, and this is important for when you start using regular expressions, because you're trying to find a pattern, not always trying to find the literal thing that's wrong. And often when you're cleaning data, if you are looking for, and this is why we're trying to think about what, pardon me.
Just kind of like he's not talking.
Yeah, just if we're trying to fix the actual instance, we don't see all the other places where the same conditions arise.
So at the same time, so what we're trying to do is we're trying to be a little bit more general. Instead of looking for that row number, we're trying to actually find out the condition. We may find more, but we also could make a mistake and find too many and start actually removing things that we shouldn't remove. Okay, so we've got to be careful here. So you've got a false positive, false negative issue going on here. But we do want to be not dealing with row numbers. We want to be dealing with conditions. And the reason is, going back to what we talked about at the very beginning, is because if I write out that CSV file, I get a new CSV file where somebody's changed the row numbers, all of my work has gone away, and I will actually get errors rather than just missing. Rather than not finding my my problems, I will actually find non-problems and start cleaning them up when they weren't problems. Okay, this is going back to this life cycle issue. Okay, so we want to be slightly more general than using these row numbers. Okay, and that's fine. Okay, for another condition, I don't know which one to use. Should we find out the ones which have all missing values for these variables? Why not county? Because county didn't have a missing value. Okay, so I have to decide what is just enough to get them, but not more, not too restrictive, and not too licentious. Another way to find the ones we cared about was to see, did they not have the word county in the county? Because everything was Alameda County, Solano County. If it doesn't have county in it, then it's. But that wasn't quite true. We actually found a more specific pattern, was that they actually they have digits in, and no county in California has a digit in the name.
So when dealing with geographic data that may change either due to political reasons, now for reference of Ukraine, or in case of California, counties appear and disappear over the centuries. Is that something we can take care of with knowledge, or do we just kind of lump them together?
Lump which together?
Like all these Americans, let's say from the year 1940 to 1960s, Yellow County did not exist, so we're just kind of.
So this is context specific. So you have to figure this out, because sometimes you might actually sort of say, look, this is in this other county, but I'm going to put it into Yolo County or something like that, because I'm going to analyze the data from now. But if I want to actually treat those separately, then I will have these weird levels of counties, which I would have to actually end up with more counties than we currently have, and I still want to deal with them. Okay, so I didn't realize that the counties do disappear. Okay, when I'm looking at the election data back in 2004, the counties sometimes just disappear. Okay, some arise. This is a problem, but it's really a question of what questions you want to address with this data. And again, it's like the missing values. What you may actually choose to do is keep the old name and the new name, and then create another column that actually has the new name, and where you map the old one to the new name. Okay, and you might use the different columns for different purposes. Okay, or you maybe aggregate them dynamically. Okay, so it really depends on the question. But how are you going to find these things? You're going to Google them. Okay, you're going to look these up and figure out what to do, and whether or not you can actually figure this out. If you had the latitude, longitude, for example, you could sort of say this belongs in this county, even though that county doesn't actually exist at the time or whatever it is. But it is tricky. But this is where you actually have to discuss what you're doing with the data. So it's hard to clean. You can clean data without knowing what you're going to do with the data, but it's much better to know what you're going to try to do with the data, so that you clean it in a context-specific and appropriate way. So what happened? If I wanted to find the county name in the column county, I wanted to find the ones which actually started with had any digit. This is a way of doing it. This is the grepl function. Okay, remember, it gives you back trues and falses. I'm looking in the county. In the string that is county name, and this is weird. This is the hieroglyphics I was talking about. This looks for any character which is in 0, 1, 2, 3, 4, 5 up to 9. Okay, this is what's called a character class. We'll talk about it. Very powerful. You actually have to go through and find, do any of the characters in the county name for each of the 400,000 county names, do any of them have? Which ones have a digit? You would actually end up writing a lot of code, okay? Or be very slow. This is extremely fast and extremely terse. So this is an example of a regular expression. And I want to show it here. You don't need it, because we can get them in different ways. We can get things in different ways, but it's very, very convenient if you know these guys, okay? Because it just makes something very succinct. And what happened? So this is another example. Again, we'll sort of stop. We'll go through this reasonably quickly and move on to some of the regular expressions. The zip codes. Zip codes should have 5 characters unless at the extended form. Okay, we'll deal with the extended form if we have to. In this case, we only have the regular form. Okay, zip codes. So that's just, so what you have to do is you have to be a detective. You have to figure out what could possibly go wrong
check to see if it didn't go wrong. And hopefully nothing went wrong, and hopefully you're going to waste your entire time cleaning the data by actually coming up with wild conjectures and finding out it didn't occur. One of the simple things is just find out how many digits there are in each of the zip codes. So NHR is the number of characters. Give it a vector, we should get back 5. Okay, and it turns out that there's only one element in this vector. It's 5. Okay, that means every single one of them has 5 characters. That's fine. Everyone happy? So these are all legitimate zip codes. Make sense? A little slight. I changed words very slightly there. When we're talking in English, no problem. I said digits and then I said characters. Okay, this says there's 5 characters. It does not say that they're all digits. So A, B, C, D, E is perfectly legitimate zip code if we just use this. Okay, so I've got problems if I don't have them up because they're not always on it. So this is a necessary condition, but not sufficient. So now I want to go through and say, okay, well, let me be a little bit more careful. And again, there's another trick to cleaning. When to stop. And the answer is after you think you should. Okay, you're just getting bored and tired. Everyone wants to go home. Okay, but at the same time, I also see some people. There are some personality types who will clean everything, absolutely everything. And about 6 years later, they'll go, okay, PhD. For a reason. Okay, so you have to know when to cut your losses. If we've only got 5 rows that have problems, you don't need to clean. Okay, but if you only have 6 rows, you probably do need to clean. Okay, so you have to figure this out. Okay. We also have some missing values here. Okay, so there's 28 missing values, which was in the summary. Let's take a look at those. Okay, let's look at the actual zip value. I don't know why I did that. Why we did that? I'm doing that for another reason. Okay, it should actually all come up. Let's do this. Here's the trick that we did. Okay, and it's easy for me. I want to check. Okay, so first of all, I could actually ask the question: do they all have digits? Remember we looked for the digit in the county? I could actually say, do all of them have only 5 digits as characters? I know they have 5 characters. Are they all digits? We can find a regular expression to do that. Okay, and that's going to be quite easy. But even if they have 5 digits, 11111 is not a zip code. I don't know that for certain. Okay, but it's probably not a zip code. What I actually want to do is I actually know the set of zip codes. They're actually all available through blah blah blah. You can send off to the USPS and actually get the zip codes, or you can get them online. Here's one way to get them online. Here's a way of actually just reading them, sucking them all in one particular as a data frame in R and 2 lines of code. Okay, now I have all the zip codes, and now what I can actually do is this. I can basically say, check all my zip codes are actually in this table. And they're not. There's 49 that aren't. 28 of them are missing values, so they can't be in that table. So that's fine. So I got 21 that are actually erroneous values. There they are. Okay, so I take a table. So I like to do the table of this. So I actually start seeing that's a typo or formatting problem. So this doesn't come out. So you can see there's a couple of repeats here. So it's easier just to do a table and count the number. Anyone figure out what's wrong there? So now we actually want to go in, look at the observations which are in this set and see the problem. Okay, that's the other thing we wrote down here is when you're cleaning data, you should spend a lot of time looking at individual observations. Okay, and when you're doing statistics, you don't look at individual observations, you aggregate. When you're doing cleaning, you look at the individual ones and find out why they're weird relative to everybody else. Anyone notice anything?
They seem to end in 0, 0.
Yeah, which is that a legitimate zip code? So again, Google this and off you go. Okay, so this is all. This did not appear correctly. There's a missing comma. So we're off by a single quote here has completely messed up this format, which makes life a little bit problematic. So you can actually go through this, go through and actually look for it. Yeah,
It's okay. I get that. It's
You might need to refresh.
just is. So good. So I since I pushed it to GitHub, I managed to correct it. Okay, good. So we can go and look through this. This is again where we actually have to go through them. This 94400 is
if we actually take a look, if you actually go through on GitHub, take a look at it, you'll see that this corresponds to San Mateo. So if you Google San Mateo, 94,400 is not in San Mateo, but 94,401, 2, 3, and 7 close are in San Mateo. This is legit, but that probably need to fix this to actually be something slightly different. We looked at this one. Take a look at this one. The other thing that we should actually do, and I mentioned it up here, take a look at the first 2 digits and check if they're both 94 or 95, because if they aren't, they're not in California. Okay, so 79 New Jersey. Okay, starts with that. But if they don't start with 9, it's not California. Again, I'm making this up. But let's see, it's like a reasonable assertion, 95, 94, so it's a reasonably good one for Northern California. So we can do that one. Was an interesting one. I Googled this with Matt. This is in Sweden. So doesn't it look like a zip code? It turns out that if you take a look at the observation, which in my formatting is all messed up, take a look at the observation, you can take a look at the city and county. And then if you go and look up that city, you'll see that it's actually 945. Okay? Which is a perfectly okay typo. Okay? But my God, Sweden is not where I expect to actually be seeing the zip code for this. Okay? So easy to fix. We can go and fix those 2 guys or those 3 guys, and that's absolutely fine. It's amazing it's a typo that is actually replicated in 3 different places. Okay, or 4. I think it's actually 4, which is kind of, so there's somebody sitting there in the registrar's office who really can't get those 2 correct. Okay, or what?
Autofill.
Hmm?
Autofill.
Autofill. The bane of Excel. Once you type it in there once, Excel will remember it. And now we just autofill. It'll be the first one up. Okay, and you just keep on hitting this. Okay, so you have, again, having to anticipate why. So it's really helpful if these all come from the same registrar's office. So you can sort of say, I need to go look at those guys and see and fix those in the future or whatever it is. Everyone happy? There is, okay, so this is the thing. So we checked the county names and life is all good. I still left these in. I didn't actually remove these rows. I didn't actually bother to. I told you to remove the rows. I didn't for a reason. For pedagogical purposes. See, they come back to annoy me. If I fix these rows and actually remove them or combine those rows into one row, the messy rows that we found through the NAs, the 4 NAs, these would not actually show up anymore. Okay, these would disappear. But now I'm going back and look, this weird one. I wonder where they are. And you go off and you find I seem to have seen this before. These are the rows I forgot to actually remove, which tells you something. The order in which you clean data matters, okay? Because you're going to see the same rows over and over again if you go back. You go in the wrong order. What's the right order? Yeah, experience tells you actually which one. But going after the easy, the small ones, like when you see 4 NAs, okay, let's go and actually figure these guys out. Here are the names of all the tables. All the cities, should I say, the table of all the names. You can look at the unique names. I like to look at the table. I like to sort it from decreasing to in decreasing mode. So, okay, because I'm assuming that errors will not occur a lot. So if San Francisco is constantly misspelled, that's bad news. Okay, so we'll see that. We might see it later on. Anyone notice anything about these? And any anomalies here?
San Rafael and Vallejo. Tick mark before and then at the bottom.
He's looking further ahead. Okay.
You go out
to the downtown.
Greater down.
The length of this is giving away, but it's actually, you're drawn to a little bit by the length of that, I suspect. Okay, if you keep going down through this, again, there's a lot of them. There's 2,810 of them. That's a lot to be wrong. Or, and that's fine. Anyone else? So there's this one down below. And again, if you sort them, you might see them. Okay? Okay.
2 Belvedere, 2 Belvedere.
2 Belvederes, if you go back up to Belvedere.
There's a case, if you scroll it.
Belvedere Tiburon. Okay, and then in other data sets you'll see Belvedere Tiburon spelled with a dash inside it. Okay, and all sorts of fun. But here, so we could deal with this with lowercasing them or uppercasing them, so we don't have to deal with these anomalies. But we still want to map one to the other. Okay.
There's Tiburon.
Right.
Yeah.
Right.
It might be helpful to print them out alphabetically.
So it might be helpful, but I think at other times you want to not print them out alphabetically, so you actually probably want to do 2 different things. And then where's the tick?
Down at the very bottom.
So
Vallejo, San Rafael.
Okay, see that's actually very hard to see. Now there's enough people in the room that we see most of them. So you yell at people, different people yell at different things. Crowdsourcing this with your colleagues is a really good plan. Okay, I'm serious. It's like you sit there, you go, I can't see it, I can't see it, I can't. Oh, that's what it is. Okay, I mean it's very hard to actually see them. This is why we don't see things. Okay, we actually programmatically check them. Okay, we sort of say, does anything have a digit in here? Does anything have a punctuation character in here? Does anything have, have a dash in here? Then we do that and we go, okay, we can find those. Those are okay, those ones are not. So you're kind of trying to whittle this down. 400,000 is too much. We whittle these down to being just 160 or something by actually just looking at the unique values. So this is always a good start. Blank names, there's only 2 with blank names.
Unincorporated.
Then we have 2 and 8.
Dixon's and
We have 2 NAs, which we don't see in here. These guys actually, if I remember correctly, come from the 2 rows that should have started on digits. Again, it's coming back to bite me to things like cleaning things multiple times. So that's fine. How do we fix these?
Can you just sub G sub that for nothing?
So what we could do is we could actually just, there's only 2 of them. We got it in places, and on this thing, I need to find that quote.
If you pull it, should be fixed.
Okay, I will in a second. So one of the things we can do is this. We just pull out I'm reading this some stuff. We can basically do substring because we only want to get rid of the first thing. If you don't know regular expressions, use substring because it's the very first character. If it's the 5th character, it could be the 6th character or the 7th character, you're in trouble because you now have to know which character it is. But you can kind of do this sort of stuff. But this is just a simple regular expression that says, and again, hieroglyphics. Really, if anyone understands this without knowing regular expressions, you're sick. Okay, we're basically saying, go find this tick that starts at the very beginning of the string. That's the universal symbol for beginning of the string. Okay, the carry symbol. Okay, that's fine. But this will basically say substitute this pattern with this, which is nothing, so that will remove the tick at the front. Yeah.
So if we're to apply this concept to like a production server or production data, do we make the changes on the original file, or do we say, okay, we have identified the problem, we think this is a better solution, we can recreate that entire column and rename it with some comments as to what we did specifically.
This is going back to which part of the life cycle are we in, and who else is using this data, and do we do this right now for the purposes of this computation, or do we actually push it back upstream for our own purposes later on, or do we push it up even further to the collaborators other people who might be using this? That actually matters, and it's not. I don't have a simple answer for you for that purpose. Creating a second column is potentially a good thing. This is always a good idea. When we're cleaning, create a second column so that you still have the old line around the place. Call it temp or whatever it is. Put it in the column. Put it in the data frame so that everything lines up. Okay, so when you subset by rows, you still get the columns matching up. That's all well and good. And then clean up and then move on. Okay, and sort of remove that extraneous temporary row column, should I say. But exactly what you do depends on the context. Okay, like I say, a lot of times you can actually just do this dynamically. Let's clean it right now, do a computation, and throw away the changes. Next time we come around, we'll do exactly the same cleaning. But that's a waste of time. Okay, but if you think that the people should know, if you should know so you cache the results, you should do that. So you can go back and change the script, but you go back and change the data. But remember, the way that you detect the cleaning for the next time around may depend on changes. It may not work when you make changes to the original database. So your code should be more robust and actually look for the condition you're looking for, not the row number or something like that. Make sense? So it really depends. There are cases. So like R is a good example. The actual R code. There was a bug in the random number generation. We take a lot of pride and care in random number generation. It was a bug. Somebody found a bug. We fixed the bug, and we left the old one with the bug. Why? Because we need to be able to reproduce that code, that random number sequence. Okay. Nobody should use it, but we have to leave it in there. So you may need to leave the old data as broken for good reasons, for legal reasons, or whatever it is. But for other purposes, you may actually want to compute on the new data. So it's
it depends. It's a very complicated problem, but being aware of it is absolutely critical. Okay, that you can't just assume that you're just making changes to the CSV file, and then somebody else gives you a new CSV file, a new Excel file, okay, and you go, oh, all my changes are broken. Okay, and that's a train wreck.
Should Substring have the tick mark in before center found and bullet home?
Yeah, it should do. This is all messed up. This is all.
Because I just want to make sure I'm understanding the function right. It finds that exact character string that starts at the second, and then it just keeps going. And you put an argument for where it ends.
Let me go back up here. Where will be? There we go.
Okay, all right. Thank you.
Unfortunately, in Markdown, that tick is very, 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 very important. And it managed that so I could tell because it was missing here on you and all the formatting is wrong on you. That makes it much clearer. This is much clearer. Thank you. So this is how you clean your actual document. Okay, so that's it. So it's the literal value, and we're pulling out the first one. We are very lucky here. It's the first one. If it was the third, but it could be the fifth one, we couldn't use Substring. We would have to know which one it was. Okay? So the regular expressions have. Everyone happy? Any other questions? Again, so this is all obvious, but it's not. Okay, to some extent, and pulling out zip codes and downloading them, it's very, very useful. And the street, we saw this one street that had 246. So I said, okay, we found one that gives me a clue. Okay, let's go and check that it didn't happen anywhere else. Are any of these streets only made up of numbers and not a name of the street? So I happen to know how to write regular expressions. Okay, so basically, what we're going to do is we're going to look for any alphabetic character. Again, this is like 0 through 9. Don't worry, we'll get to these 0 through 9. This is now A through Z or capital A through Z. Okay, finding any character. I would think 246A. Okay, is probably not a good thing because that's the apartment A. Would not be a street name. But I'll be very flexible just to get a quick view. So I'll look in this, and by the way, what I'm going to do here is I'm going to say, oh, by the way, I'm not looking for that. Matches it. This doesn't happen, which means that there's no alphabetic character. And then don't tell me which ones it matched. Show me the actual strings in which it matched. And this is what I get. This is pretty clear. Almost every one. So like 4 out of the 400 and something thousand. 6 or 7 of them have no alphabetic character in the street. Pretty good. Okay? Some of them are just empty because they didn't get the street name. That's easy. Okay? The 246 we found to be complete trash. Okay? So we fixed that. That one? Anyone? It smells like it's sick. Okay, so now what we do is we go and take a look at that one. Okay, we go take a look at that one. Blah, blah, blah. Okay, that's where it is. So this one should be moved over. Bedrooms again, unlikely. Okay, that must be brother and sister who own a house with 1,400,000. Okay, so we move these. We can move these guys over and fix these. This is life is good. We can also actually check to see if street is actually in the zips that we downloaded, because we downloaded all the zips, so we could actually check to see that sort of stuff. Everyone happy?
So hopefully you can see there's some uses for regular expressions. I think we should maybe move to how they work.
Yep.
Because we're throwing them at them, but
we're almost done. Here's another data set. Okay. Again, this is another nice data set. Again, it should be there. Let's do this. CSV this guy. Okay. Call it D again because I call everything D for data. Okay. We'll just read this guy in. What do we do here? Summary class, sapply, D of class, div of D, names of D, summary of D. Okay. Okay, and I have not. These came in as factors because they didn't say the strings as factors. It was false. What we've got here is some nice data. Okay, these are manually generated data by actually people reading journal articles and actually collecting the first year of occurrence, the last year of occurrence, the country, okay, and related to the PDFs of the actual journal articles they were reading. Very useful. This is incredibly useful stuff. Hand entered into Excel spreadsheets. autocomplete, all sorts of interesting things, cutting and pasting, Excel deciding that Windows is different from Mac, and characters are getting put in and stuff. Dates getting put in as 12/1/1960, getting converted into weird things, all sorts of opportunities to go wrong.
One, I should say, going back to programming defensively, you should just assume that data entered by hand will have issues. Even like the best of us mess up in Excel and mess up entering data by hand. So don't say, well, I'm better than that. And I'm like really on top of my thing, and I had lots of copy and I paid lots of attention, because you didn't. It's almost impossible to enter data by hand correctly. So just assume you did.
And it's also almost impossible to clean data by hand correctly. Okay? And this is what I was getting at. Look at those names of the cities. We went through them. Not everyone spotted an error. Not everyone spotted all the errors. Okay? And you really want to programmatically sort of come up with questions like, does it have a digit? Does it have punctuation? It shouldn't have punctuation. You can test more things than you need to, but you'll find these things. It was great when I went after the 4 missing values, because there's only 4 you can see. When I got 28, it was hard to see. When I get 160, it's almost impossible to see these things clearly. So you always want to be doing things programmatically. That's hard because writing code is hard. That's why the more tools you actually learn to do this, the easier it gets. This is where the regular expressions are, again, the Swiss Army knife. They're really, really useful because they just pull them out, do something very, very terse and quickly, but there's a learning curve. Yep.
Can we apply, so CAPTCHAs effectively take, it's issue for you, so difficult to write code to identify and say house number and have person spend an infinitesimal amount of their time to do it on your behalf.
Oh, you can have people clean your data, but so there's one problem with I don't let people clean that data. Okay, because people make decisions. Okay, so this is a big part of it. People are making decisions. If they give me a long set of notes about the decisions they made, I won't read it because it's too long. Okay, if they give me a short list, I won't trust their data because they made decisions I don't know about. So here's the problem: people will censor the data. People will go off and they will actually make decisions on my behalf that will change the analysis that I'm on, the conclusions I'm going to make. Okay, so that's a real problem. Okay, but yes, you can actually, if things are nice and simple, where you can literally just deterministically, and you can trust humans. So there's you can do this. So the mechanical Turk and all this sort of stuff, you can dispatch it off to people, but you can, or what we call, see, I should say this in undergrads. You can actually do that. You can do this. It's a really good idea to actually have redundancy in testing. And if both people don't give you back the same value, then you've filtered it down to be a smaller set, and then you can take a look. But it is really scary when people actually clean data for you and don't tell you what's happened, and all of a sudden they've removed a whole other observation that you care about, that they're, especially rare events, or that they've imputed a lot of data. They put the mean in and didn't tell you, and you think you've got bigger sample size than you actually do, and you go around making ridiculous claims. Very bad example. Okay, so again, context. It's not a bad idea, but it's not without its problems. Okay, everyone here. So basically, this is the. We've only got 4 columns here, 4 variables. How hard can this be? Okay. Okay, so we read these data. I think I actually did the string of this factor, so maybe actually go back and do that. It's actually a good idea to, when you're cleaning data, to keep everything as strings, so that not factors, so that because you haven't actually made your mind up about these things. Okay, so I will do again. Okay, so we actually have this. Now we actually get even less information. Okay, because we don't actually have these. Anyone see any problems?
First year is a character.
Year first is a character, which means that it should be a year. It should be 4 digits. It didn't come out to be right. Okay, so that's the first thing we're going to actually go fix. Okay, so take a look at this. That's the other thing you do. Take a look at the first 5 lines. The next thing you do is don't assume the first 5 lines are in any way representative. Sample 5 lines because it's time ordered. It may be very specific. Okay, so head of D and then D square bracket sample.
The n row of D with 5 or 10, or and the more you look at, the better. But this is what we're actually sort of seeing. You have this sort of data. Got a bunch of empty values here, right? It's good. Between these, okay. So let's just take a look at the year first, okay. These are the unique values. Okay. So again, I love to sort table of this guy. I don't want to see them all. It's too overwhelming for me to actually see this. Let's just take a look. These look good. A lot of empty cells here. These all look good. Life is fine. Happy, although we know that they're not. We know that they're not integers. Let's take a look at this. There are 365 unique values which did not turn out to be integers. Regular expressions, find this. Matt wants to use regular expressions. I don't want to use regular expressions. There's supposed to be a year, which is 4 digits. Just turn them into integers. If R can't do that, they become missing values. Okay, that's the fastest way of actually checking to see is this a number. Okay, so we just take a look at these. Anyone spot anything? This one's an odd one. Okay, this is cut and paste and bizarreness. Okay, and all sorts of ways. But first thing we need to do is get rid of that. Anyone know how to get rid of that? You got, I forget how many, you got 4,000 rows here.
Nothing greater than so many digits.
Well, but the trouble is actually, I may want to keep this U23. In this particular case, I don't. I actually literally want to get rid of this.
And before you say fix it by hand, if you open this in Excel, you don't, depending on what version of Excel and what your locale is set to, you might not see those characters.
This is what, and people go, I don't see a problem. You go, looking at it straight up. So you take a screenshot, you send it to them, and they go, I can't see it. Okay, so if you have this is a very problematic issue. Okay, so this is what we do. GSub. Remember what I said? These functions. There's a couple of them. grep and grep. Find the elements. We find the observations for which we can find the pattern. We have to figure out how to write the pattern. Okay. GSub and sub for substitute in the value. Where we find the pattern, make these substitutions in the text. And this is what we're going to do. We just cut and paste this, and we say substitute these 3 digits, or these 3 characters, should I say, in a row. And that really means in a row. You must find this character, followed immediately by this character, followed immediately by this character to be a match. If I find it, I then replace it with whatever I want, but I'm going to say nothing. It's the empty string. And then it goes on and continues to match. So when we're looking here, it says, did I find a match? I'm looking for this. Okay, I'm looking for this character here. Did I find it? No. Okay, keep moving. Did I find it here? No. Did I find it here? Yes. Okay. Take a note. Okay, I found a match. Did I find the next guy? Let's say it didn't. It would go, no. So it backs up and then it says, okay, keep moving. Throw away that note. Okay, now, but it did actually find this character, then this character, then this character. So I found what you're looking for. What should I do? Replace it with empty. Okay, and then it keeps going again because we use GSub for global substitution. Okay, if we just said sub and just do one, say I'm done. Okay, but GSub says, no, you do it everywhere you find it. So now it goes on, it moves on, and says, and here we go. So it'll just actually remove all of this. And this is what the regular expression matching engine is doing. It takes your pattern and it does it character or element by element of the pattern. I'm looking for this. Okay, I found it. I didn't find it here, so move on. Move on to the next spot. Potential target. Didn't find it here. Keep moving. Now I found it. And then it keeps moving until it fails. And then it starts again at the next available spot. When it does match, it continues to eat up until it finishes the match. And then it says, I found the match. What would you like me to do? In some cases, it will say true, a match. Other cases, it will say here, it's element number 4 that matched. Not in the string, but on the vector that we're looking at. And in the case of sub, we're actually substituting text. Yeah.
So on a matter of explaining data like this, is it ever possible to do it in parallel, whereas everything has to be sequentially with one person in one instance?
No. You could each take a column and you could fix it. Fix the columns. But what happens if the error is actually this combination, that combination of those 2 columns can't happen? So we have univariate statistics, so we draw histograms, okay, and density plots and stuff like that, and that's great.
Okay, so you can go fix those. You can say this bedroom private, this number of bedrooms being 1.45 million, that's unusual. Okay, that's wrong. But then if you want to go fix it and move that into the whatever it was into the price, well, if somebody else is cleaning price, they might actually also clean it at the same time. But if they're not looking at price, they might actually remove that row because it's missing value. Well, this is complicated because we actually have joint distributions that we care about. Okay, so the answer is what we do is, and I mentioned this near the end of the other cleaning the house price data. We tend to basically do clean univariate, clean each column. Okay, when we find you find the anomalies in the column, and then you look at the other observations. You look across those, see if you can fix them all, fix that row up. Okay, eventually we finish all we can do there. Then we look at pairs of columns, and we look at weird things. So we draw scatter plots, for example. We draw scatter plots, and we sort of see things like this. Everybody's happy except for that guy. And we go, we would not have picked this guy out because he's actually not too extreme here. Let's draw it over here. Okay, this guy is not very extreme here. And we put it down. Over here, it's not very extreme here either. We would not have picked it up in either case. But we pick it up because we look at the joint distribution and go, that's just weird. That's somebody messed up here. Okay? And then you find out that, depending on how I draw it, if we flip, this is X and Y, if we flip Y and X, it ends up banging here, and we go, that's the problem. In that case, you have to look at both simultaneously. For those of you who care, there's a fun, we'll just look at this. You can take a look at this data where it's actually very hard to see weird things happening. You have to actually not look at scatter plots, but actually multiple plots with 3 variables simultaneously to actually pull out the weird thing. If we have a moment, I'll show you that. Okay. Okay, so basically when you're cleaning, you start with univariate, then you go to bivariate, then you go to trivariate, then you go, okay, and you start looking through the whole way through, okay? And you have to be really clever to actually come up with weird features and weird anomalies. And we'll see how convenient this is. So if you go ahead and do this, we just remove this, they all disappear. All those weird characters, that triple weird characters disappear. Actually not quite true. But okay, they will do exactly what we wanted it to do, and that's fine. Now we've actually got a much smaller set of things to look at, much less wide things to look at, so it's easier to see. Okay, so again, a big part of this is actually being able to visually see the problems. Now, so these are the dates. So these are the patterns I'm looking at. I just pulled out a few representative ones. That's a date, but it's not a year. Okay. We've also got a few other ones there. We've got other forms as well. I don't know why you didn't pull those in. Where did we get there? We got. I don't have those included here. Okay, so we'll see some other ones. But again, so what we actually see is this: we see things like day, and then an abbreviated month, and then a year, then day / month / year. We have to preceding slash. Okay, and so we want to actually go and identify those. Okay, how do we identify this? This regular. Remember, I told you regular expressions are really annoying. You have to be so exact in what you mean. Okay, they're really annoying. What I actually want to do, and I like to write them down in sentences. I am looking for 1 or 2 digits followed by, and you can write these down as I'm looking for this followed by. Okay, every sentence must end with followed by or that. All right, and at the end, I may even have to sort of say followed by the end of the string, or a space, or another word, or something. I may have to be very specific about what happens after the bit I'm looking for. Okay? I'm looking for 1 or 2 digits, because this is the day of the month. So it could be 1, or it could be 10. But I need to be able to handle 1, not 0, 1. Okay? I need the month, which is actually, okay, and they're not in the actual output here, but they are. You pull them up. It's actually something like August, capital A, U-G. So I'm going to say, and this is not right, it's followed by a, ignore this followed by, okay, by a capital letter, A, capital letter, followed by 2 characters, U and G.
but not anything else, okay? And then this should also be followed by a dash. Okay, I'm missing the followed by dash. Okay, that's the dash. I need to specify the dash here. Then followed by a year, which is 2 digits. I haven't shown you this data. Okay, it's actually 2 digits in this case. If we were looking at the slash data, this version, the people who entered this actually used 4 digits. Why not? It's perfectly fine. Okay, it's just, but there's different people out entering the data. Sometimes this is actually another really good trick. When there's multiple people entering the data, we ask them to record who entered which row, because we will find out the same people make the same mistakes, typo, okay, or they have the same conventions. And this really helps us. We actually separate these out and go like, let's just discard all the data that person collected because it's all wrong. Okay, and they're just totally, they're off. So when they measure things, they're plus or minus 1 million versus everyone else is plus or minus 10. Okay, so we want to actually be able to write this. Okay, this will not do what I told you. It will not find August and differentiate between something like AAA. Okay, so I'm not actually finding abbreviated month years, but hey, I don't care, because I'm just doing some crude approximations here. Okay, it will also follow by 2 digits. If I see 99, it will capture 99. Okay, which is not 2099. Okay, because this is data. This is a regular expression. Told you. Okay, it's actually not very hard. We can make it easier to read, but then we have to know a little bit more tricks. But we've seen this already. What does this mean? Okay, it says match 1 character out of 0, 1, 2, 3. And I could write this if I wanted to, and I'm going to go quickly here. Okay, I could write this down 0, 1, 2, 3, 4, 5, okay, up to 9. But I don't want to find 0 followed by 1, followed by 2, followed by 3. Okay? I want to say 0 or 1, and I'm going to write this as 1 because otherwise, okay? Or, now this looks like R, this looks like the or in R, isn't it? Or in R. You can't say that. The Irish guy can't say that. That's racist. I'm Irish. I can say it. This is actually a regular expression, a vertical bar, which means this or this or this pattern. Okay, they don't have to be single characters. This is what's called alternatives. Okay, so I could write it like this, and then I have to, like in arithmetic, I have to sort of say it's this or this, then followed by something else afterwards. Okay, so we're just going to piece this together. It's a very simple language. It's kind of a logical language with very few elements. I like to say that R has very few elements in the language. This has almost none. Okay, in the slides that we threw up. Over here. And there's a list of the guys that we actually care about. Okay, there's very few elements, and I've just already covered several of them. We can find literal characters. In the G-sub, we said find this weird Y in Japanese, followed by the E with the bizarrely followed by the underscore. So we can easily say, look, find this literal sequence of characters. Okay, that's fine. Here we're saying, oh, here we're saying find this literal sequence of characters, which is one of them followed by a dash. Okay, so I have to say it's this, or this, then, and this is one pattern followed immediately by this. Everyone with me? So this is an or. This is a lot to type. So this is the same thing. Yep, that's why we use this notation. It's just more convenient. And if I wanted to just do 0 through 6 and then 8 and 9, I could do that. This is just a range, and then I'm missing out 7. Okay, everyone happy? This is just an abbreviation for this. Yep.
Would you have to put in another or line in between 6 and 8 there?
No, I do not. I better not.
You just put a space.
I don't put a space. I do, because no, if I put a space in here, universal, then it will include the space.
So these are character classes. Inside the square bracket, it's saying this is a set. Okay. And if you match any one of these characters inside the square bracket,
it's a match.
It's a match. So if you put a space, now a space is one of those sets. characters that it's going to match against.
So how does it not read it as 689?
Because it's only looking for single character. If you want to think about it, it actually takes this and makes that. Okay? Okay, so it literally just will it will rewrite this as 0, 1, 2, 3, up to 6, or 8, or 9, and that's the same thing.
Okay.
But it can only match one character in this pattern. Okay, it cannot, because that's how it knows how 689 cannot be 689.
You know, that's for character sets of one digit.
One character.
So the magic is the square bracket. If you didn't have the square bracket, you would look for 689.
So again, this is a quick crash course in regular expressions. They're very simple. And again, kind of demystify them, but also show where they use them. That's all we're saying. Look for a digit. Okay, any digit because they're from 0 to 9. Okay, just one of them. Look for another one immediately following. It has to be one digit followed by another digit. And this question mark. Okay, so so what we've got, and I need to pull up my slides. It's in the slides. We have literal, so this is where we were looking for this Y with the E. We're just looking for literal strings. Then we're going to actually look for these character classes, because kind of what we actually want is it's one of these. Okay, so one character out of this set. Okay, so this was 0 through 7, let's say. Okay, that was just, again, we can make any range that we want. That was just as match one of them. Okay, but I need another thing here, which is this, because I am lazy, and laziness is good. Okay, so one is, I remember I wanted I wanted dates to be 1/August. Or I wanted 11//August or -August. I want to be able to handle single-digit days and 2-digit days. This says you have to have one digit, and the question mark says applies to the preceding element of the pattern. It says it's optional, 0 or 1, but not 2. Okay, but if it's not there, I'll go on. If it is there, I'll include it in the match. Okay. And it only applies to this guy here, not to this guy, because it's just to the most adjacent one. Then we need a literal character, dash. That dash and this dash are totally different. This is inside the square bracket, which means it's a range of numbers. Okay, and on a Tuesday, it's totally different. Okay, so this is kind of weird. You need to learn this rule, but they're not very long. Yeah.
And not inside the brackets before the question mark. Could you just have one set of brackets for 1-12?
If I could, no, okay, if we were to do, okay, these are, by the way, this is such a, one of the problems with this language is it's designed for use not to be intelligent, but just to be very used. Yeah, when we design language, if you did 1 through 12 inside square brackets, yeah, that's what you're saying? Yeah. This would say 1 through 1 or 2. Okay, which is not what we want, because remember, this can only match one character. It can't match one followed by 2. Right. It's really annoying. You kind of wanted to do that, but that's fine. So we kind of basically just say, okay, 0, this one followed by this thing on optional. So we have a quantifier. And there's various different quantifiers just for fun. So we have different types of quantifiers. We have optional. 0. This means 0 or 1 of these guys. Star means 0. I'll keep on saying 0 or more, meaning up to an infinite number. If you have an infinitely long string, you can have an infinite number of them. Okay, we have plus, which means at least 1, but you can have more. Okay, and then lastly, we can actually do this m, comma, and another weird syntax which says you have to have at least m of them, and you can't have any more than n of them. Okay, to make the match.
Those are curly braces.
Okay, these are. Now I'm getting my font. Okay, and then you can actually have a trick, which is m, comma, nothing means at least m of them, but I'll allow an infinite number, and then if you leave out the m and have an n, you can have 0 or up to n of them. Okay, which is very handy. Okay, so you can actually now read this. We're looking for a digit followed by an optional next digit followed by a dash followed by a capital letter followed by a lowercase letter followed by a lowercase letter. These are not optional. You have to have 3 in a row and no more before the dash, and then you need to have 2 digits. Everyone happy? Regular expression.
Yeah, since these are dates, couldn't you anticipate that the first block should be 1 through 9, because you don't have any months? I guess you do have months that start with 0. You could have like 0-4 being April.
Oh no, the date. These are the. We're trying to read this stuff. The month is the second value, and they're abbreviated names that it shows. Okay, so
Yeah.
we'll get over to the other one where they're actually in digits, and then they're I can't even remember where they are, the first or second character. This is the day of the month. Then this is the month. Later on, we'll swap these around just because Shay wanted me to.
Wait, how does the plus refer to more than one?
So if I were to put a plus in here, so suppose I put a plus in here, that would say I need 1 digit, and then I'd say I need at least 1 more digit, but I'll eat up as many as you need until I find the dash. Okay, so if I wrote down, okay, if I wrote down this, I wrote down 0 through 9. And 0 through 9 plus. That would match, and you can just do this. By the way you learn regular expressions is you come up with some test cases, some that you want to match and some that you don't want to match. And then you see if they match. And if they match too much, you're wrong. If they match too little, you're wrong. And you get it just right. Okay? Okay, and the real way to learn regular expressions is not to use, you use grep to see which ones did it match. And then when you don't get the right answer that you expect, there's 2 steps to this. If you get the answer you didn't expect, you check your expectations, because oftentimes you're wrong. Okay, but when you know you're right, then you go and say, what did you match? And that's when you use greg-expert to say, where did you match in the strings? Okay, so you actually now say, okay, you matched this, but I thought you'd match much more. You didn't match anything. I expected you to match here. Why not? This will match 1, 3. Okay, that's fine. It will match, so we have strings here. It will also match 1, 3, 4, because this is more. So if I put a minus in here, this will match 13-August. This will match also August. Okay? It will not match this 1, 3, 4, A-August. Okay, because that A is not in here. But it will match here because we're allowed to consume more here. There's another issue here is this thing will try to match as many digits as it possibly can before it hits this dash. Okay, so if you wanted only 3 and you have 5, it'll eat the 5. It's what's called greedy, okay, which is a really powerful thing. So we really irritate. Okay, so you need some ways to say don't be greedy, and there's a way to do this. Yeah.
So question, yours, what if they have it in a European format or it's Europe?
Oh yeah, that's up to us to learn and decide. Okay, that's why I was teasing Shay. Shay and I write things the right way.
Well, I drive in the other side of the river.
I'll be driving on the other side of the road. He gets into trouble. Yeah. Okay. Yeah.
What would happen if you were trying to like get rid of examples like 49? Like you didn't want someone to be able to enter the day as 49.
Okay, so very good question. And also the one I alluded to, which is if somebody has a month called A. We're going, I'm looking for 3 characters. Well, what we're going to do, what we would actually do is, okay, so let's begin while we're here, okay? This I like to do by good examples, good motivation, okay? So we want to exclude 49, okay? 49. So I've actually told you enough here to do this. We've actually got almost all the bits you need. So we want to avoid 41. We'll put a dash in here, okay? We want to avoid that, but we do want to allow 1, 4. Okay, so let's change this to 41. Okay, so you don't want to allow that. So what I could write down is I can sort of say, okay, and we also want to allow just a single digit, so 8 dash. Okay, so I could say, okay, it can be 0 through 9. Okay, and then it has to be a dash. Yes. You're also telling me it could be this. It could be a 1 I'll do it this way, 1 followed by 0 through 9, yes? It could also be a 2 followed by 0 through 9, yes? It could be a 3 followed by 0 through 9. Nope, nope, okay? Let's back it up. This is how you write these things. You write them and you go, okay, no, okay, gotta back up, okay? And then we'll try to be a little bit smarter, okay? 3, this can only be a 0 or a 1. The 2, not so much, okay? Except an island. Okay, so this is this correct? So now, let me just write this like this. No. Okay, okay. Do you agree? This is, if I put this all on the same string, okay, with no spaces, no new lines. I put a new line in here, it's looking for a new line. It just trusts me. Look, if you put a space in here for punctuation or readability, it's going, I'm looking for a space. Okay, it's very, very literal. But so does this make sense? Yeah.
It could also be 0 and then 1 through 9, right? If somebody puts in a dated 0, 1 or 0.
Who does that? Yeah. So we could do this. So it could be this. So we would actually we could allow 0 followed by 1 through 9. Yeah. So we can make it more expansive here. Everyone happy? See how I would build this up? I told you about alternations. We built this. This is very verbose. I'm going to make it slightly simpler. I'm going to take these 2 out, and I'm going to write this as 1, 2, followed by 0 through 9. Okay? This is just me typing on. Everyone happy? So I've got 2 lines down into 1 line. But it's the same thing. I'm just going to separate these with vertical bars, and life is fine. The one thing I'm going to have to do here, because I want to follow this by a dash, I need to put the parentheses around them, or else it'll look for this, followed by or this, or this, or this, but the dash will go with this, not with all of them. Okay, this is just like arithmetic when you don't do the parentheses correctly. Okay, everyone happy? Okay, and now the question is, can I do better? I could do something like this. I could get rid of this guy. Okay? And then about 3 hours later, I go, look at me, I've written the world. Oh, where's everyone gone? Okay, because sometimes you just don't want to write. You just want to write enough to get the right answer very quickly. If you're writing this to be very, very robust, be careful about them. But be careful, yeah.
So what if I want to find a question mark or a square bracket?
You don't know this? Sorry. By the way, we'll go on a little longer. Feel free to leave, but we're happy to answer questions, but don't feel compelled to stay. And the thing about this is the following. The other thing is, like, suppose I didn't care about this. Suppose we were. I have to come up with a good example, but I actually don't care. I'll let anybody have anything in here. So it could be 0. Okay, and I can have any character in here at all. How do I write that? I could write it down as A through Z, capital A through Z, capital Z, see how it is Z. 0 through 9. Any other characters? Bang, question mark, blah, blah, blah. Okay, all of these things, I can't come up with it. How many people speak a foreign language? I cannot write all of these things down. I cannot write the entire vocabulary down, all the alphabet. So there's a very nice little thing called a wild card. Okay, and wild card is match any character. One character, any character, dot. When I use dot, I mean not dot, I mean anything. Okay, so what we've actually got is dot is a special character. Special character. Dot is one of them. Question mark is another one. It means 0 optional. Plus, star, curly brace, optional. These are special characters. So square bracket over here, special character. How do I actually find a dot, like in an extension on a file name? How do I find a dot, or how do I find a period in a number? So it should be these 3 digits followed by a period. But that could match, if I put dot in there, it could match a letter, which is not good. So how do we do this? We actually escape it. Oh, here. Okay, I'll stop there. Okay, we'll just do 2. Okay, in R, I need to say to the regular expression function that dot. What I mean by dot in this context, if I mean it as a wildcard, I just say dot. If I mean to say, I mean the literal character period. Okay, I need to put 2 slashes in front of it. Why 2? Don't ask me. Okay, there's a reason. It makes sense. But it's in there. Okay, and likewise, if you want to actually have a question mark, if I actually want to look for sentence, text, sent a question mark, I put in slash. I can escape any character, and it now becomes, I literally mean this, not what you think what the language, the regular expression language means. Yes?
The little backslash is just an R specific.
In Python and other languages, we use 1 single slash. Okay, in R, we use 2 slashes. Okay,
Like the safe place.
it's just, yeah, there's a reason to say, I can explain the reason, but that's not. Okay.
So it gets a little silly if you want to find the backslash.
You can just use 3 or 4.
Yeah.
Which one? I can't remember. I mean, experiment to figure out what it is. Okay, by actually doing a test. It's 4. Okay, so
And one thing I'll throw out there before, one thing, if you're used to word processing and stuff, a space is a character. So the wildcard picks up spaces, it picks up anything. So that threw me off for a long time. Like, why is this matching? Oh, it counts as space as a character.
So there's one other thing that we mentioned earlier on. Again, there's these other characters, there's special characters, and you saw them, and that is this caret symbol, and also the $sign. Okay, and this means the beginning of the text, the beginning of the string, and this means the end of the string. Okay, which is really helpful. So say no, because I might be looking for a date which has to begin at the beginning and end at the end, and not other text. So we saw things like autumn 2003. I may not want to accept that. I may not. So say no. The digits have to be at the beginning and end at the end. So we have all these different things. Let's say if some of you get ready to go, feel free. I'll just off you go. If there's no one here, I'll stop talking after 1.
And the GitHub material is up there to read through it, and also it'll get updated. So we're fixing errors as we find them.
And so one of the things we actually do when creating this, we go grab some of them, and then we see what we have left, and then we go fix those. So we'll go after these guys next. We look, and this is a very similar pattern. Okay, the day of the month, and the year. Correct? That's the only clue we have that this is actually the day of the day of the week, the day of the month, should I say? So how we actually. Good news is we only care about the year, so we can actually. So we just can actually go and find these 2 patterns. The one for finding the day dash month dash year are very similar, except for they have slashes in between the separators. So we could actually combine those, but also the day of the month is actually is a digit, whereas in this middle part is August, January, February, March. So that's a little bit problematic. So we'll actually go through and actually pull out all of these different things. These are all very, very similar. See what we're doing here with the 1, 2? We're looking for 1, at least 1, but no more than 2 digits. This is the same thing as 0 through 9 optional. 0 through 9, yes, and 0 through 9 optional. Okay, so that'll give you 1 or 2. So that's a perfectly legitimate thing to actually go and do here. As we go and filter all these things down, we end up with this. What are you going to do with those? Drop them? Oh, we don't like dropping them. We're going to drop these because they don't actually have a year. But one of the things, if you look through the notes here, what we're doing is we're actually doing a substitute. We're actually, and this is the one important thing that we're actually doing here. Okay? Let's take a look at this regular expression. This is one thing that we haven't talked about, regular expression. What I've done is I've said this. It's 0 through 9, a digit, or 1 followed by 0, 12. This is the month. So this does not allow the month 23, okay, or even 13. Okay? What I've done is I've done that, and I need to put the parentheses around because it's either this or this. Okay? Because this is 1 character, this is 2 characters. Then I say it's a slash followed by the day of the month, which is 0 through 9. I need one or two of them, okay? This will allow 33 to be kept to come in, but we could go in and do that thing we've done over there, but we're not going to bother. And then I've got this, which seems a little bit redundant here. I've got parentheses in lots of places. This is 19 or 20, meaning 1900, 2000, followed by 2 digits. So it's 1999 or it's 2012. Again, we haven't constrained. If we get 2027, that's okay. We'll deal with this. Okay? But I put these parentheses here for a reason. Okay? There's no ambiguity here. When it reads here, it's going to just say it's either this or this. This parenthesis is fine. But I put these parentheses in for a very important reason. Okay? I don't want to match this text. When I write it in here, I don't want to match this and say, did you match? I want to say, go get me that year. Okay? And I don't know where you matched it, but I want that match. Because what I actually want to do is, I want to replace this string with the value 2015. And I want to replace this one with 2014. Make sense? Because then I'm going to stick it into the year. So I'm basically throwing away this stuff. We have 2 choices. You can either throw away stuff or you can extract the stuff you want. Sometimes it's easier to throw away, other times it's easier to extract that you want when it's more specific. This is what's going to happen. I match this. First of all, I have to say, I'm looking for a string that has this pattern. So first of all, it says, yes, I matched. Oh, and by the way, I put these parentheses. This is block 1, this is group 1. This is group 2, and this is group 3. Every set of parentheses has a number. 1, 2, 3, 4, so 9. If you have more than 9, better. Okay? Happy? Everyone happy? So this is what we do down here. I basically say G sub with this regular expression. Okay, so I'm substituting. Match this thing, and what do I replace it with? Number 2. Not a fixed literal string, but the actual contents of what I matched in group 2. I think I'll get it here. Okay, make sense? It's a little weird. Okay, it's a convention. This is language is all about convention. It's a very logical language, but this is actually allowing me to, I can't put in 2015. I could, if I wanted to, go in and sort of say, look for this and look for 1991. And then replace that with 1991, and I do it for 1992, 93, but I don't, sorry, okay? So I can, what I'm basically going to do is I'm going to be clever like this, and I'm going to say, okay, go match this thing, and then just pull out whatever you matched inside in this part of the game. Okay? And that could be 4 digits, it could be 6 digits, it could be huge, it could be very small, it could be nothing. In which case, we'll just match whatever I match. Everyone happy? So that's, these are what are called back references. So over here, we're referring back to what we actually matched. It's even weirder. So I know you've all seen this, because you've all done it, everyone's done it. When you're typing away Word or whatever it is, and you write down the, and then you write down the, okay, that's this word followed by this same word. If I want to find all of those, I can say grep. Let's find the occurrences. And so this is a, okay, sentence starts, okay, all big long block of text. Let's call this X. So I'm going to grep inside an X. I'm going to look for, let's say, A through Z, many of them, followed by a space, okay? Let me put a parenthesis around here. Leave the space out, yeah? How would I find 2 occurrences of the and the, and A and fish and fish?
Backslash 1.
Exactly. I'm using them in GSub, but you can use them inside grep, actually in the same pattern. I'm basically saying, go find this pattern. Oh, by the way, there's a parenthesis around it, so immediately, when I find the match, I immediately call it 1. And now I can refer to 1. Okay, and go, wow, hey, that's handy. Okay, so I can now actually find, so I could write that, go find the and the, find A and A. But what if I want to find fish followed by fish? Okay, well, I have the same pattern, which is find something and then find the next thing immediately after the space. Okay, or whether it is I find it 6 characters later. Everyone happy?
Any questions? Yeah.
So just if you do have more than 10 groupings or 9 groupings, is there syntax to reference them, or is it really just?
So if you really want to, so remember I told you these things have so regular expressions are what we call domain-specific language. Okay, they're first of all they're the same set of regular expression rules as literals, character classes, modifiers are everywhere. Okay, in every single language you have some facility for doing this, but then there becomes dialects. Okay, so or extensions. Okay, and in this book they talk about all sorts of different extensions, and Python has a different set of extensions than Perl and R. Fortunately enough, there is a very common set of extensions called the Perl compatible regular expression library. And one of the tricks in there, you can do all sorts of things, including things like non-greedy matching. So instead of actually each bit, eat up as much as you can say, don't eat up as much as you can. But you can also do these things where you can actually, you can name these paths. So inside the parentheses, you can use question mark, colon, and a name. And you can give it a name, and now you can refer to that name. Instead of /1, you can now refer to the name using some particular syntax and difference in Python and Perl, but you can still do it. And that's a really important thing, because this is why regular expressions are so annoying when you do this, is I do this, and I do this, and then you come along, this matches 99. So somebody says, can you make it not match 99, but match 0 through 9, and then 2 through, well, this is what we do, what are we talking about here? This is the day of the month, this is the day of the month. So we go up to 31. So we write out this big long expression we had before. So now I would need parentheses, wouldn't I? Because I have multiple ors inside in this grouping here. So this is number 1, this is number 2, and this is number 3, yeah? And now I go back and change this to make this number 2, and this becomes number 3, so this line of code has to change. So this is highly unstable. Okay, whereas named blocks would just say, look, it doesn't matter, it's not moving. The position may change, but not the name. So it's a very, very useful thing to do. But then you can't run it in all systems. Okay? But we have these things. One of the things you'll note in all of these functions, grep, gsub, greg-expert, they take your vector, they take your pattern, they take your the vector and so forth, and they all have this extra argument called Perl equals true or false. Okay, by default it's false, which means we just use the regular extended version. But if we use true for Perl equals true, then we use the Perl compatible regular expressions, and it's an enhanced dialect. Everything will work, but more will work as well. Make sense?
Yeah, does that give you things like names, character classes, then so you can say a digit, name, 0-9, all that kind of stuff.
Oh, the named character classes come for free.
Okay.
It's the named grouping that we actually care about.
Right.
That's the big extension. What we actually said over here for those, so you already know about this. When I type out A through Z, anyone see a problem with that?
No.
Well, lowercase, let's make them all lowercase if we want, okay? What if you're not English? Okay, so for the racists among us. Okay, if your alphabet doesn't have 26 letters that look exactly like this, you kind of got a problem. We already saw weird alphabets, weird for us. Okay, perfectly normal for everybody else. So this is actually very helpful. We can actually write down something like the following, which is we can just write down alpha. And we can also write down digits, okay? Okay, and this says, we're opening a character class. We're looking for single elements inside in here. But this says, it's very confusing. We have another square bracket, but they immediately come with a colon after them and have a corresponding colon square bracket. And this says, whatever locale you're in, use its alphabet. Okay? So now your code is ported. Okay, which is very, very helpful. And digits, if you happen to use different digits, okay, if you happen to think your digits are 1 and 2 and 3 and 4, okay, they're your digits. That's going to cause you grief because there's multiple characters there. Okay, so that better be a single font. But this will adapt. And likewise, by the way, can anyone list off all the punctuation characters?
without looking at your keyboard. Okay, and in fact, you may not want to. Okay, so you can actually put in punct. Now, can anyone name off all the white space characters?
White space characters?
Oh yeah. White space is, white space is a space, a tab, a new line, carriage return, and a new line together as one single character, but not actually treated as that. Oh, good grief. So this is why we actually like to say, punct, we actually like to say things like space. So these are named characters. Much easier to read, because who wants to tell me what I mean here? JKMNOPQRSTUVWX. What? Okay. I left one out. I left out L intentionally because I don't want to match L, but you can't tell us. You have to read this and actually go, what do we mean that? What do we mean that? Okay, whereas this is much easier to say. It's just all the alphabetic characters. Okay? Okay, or whatever it is. Or in my case, I actually intended to leave out Y and Z, so I would just go A through X. And that's up. This is so much easier to type, easier to read. And you all laughed when I showed you some regular expressions. They are horrific to read. So think about when you come back about 3 minutes later and try to read your own regular expression. What the heck was I going for? Okay, they are really, they're hieroglyphics. Okay.
I should say that for a lot of common tasks, finding phone numbers, email addresses, and addresses, that people have constructed regular expressions, and they tend to be, they're huge, long things, and it's hard to make sense of them. So if you want to see complicated regular expressions, look up. I think the email addresses can be pretty horrific.
But at the same time, like with everything, don't write them yourself by looking them up and try to figure out how to write them yourself. Just copy them. There are, likewise with natural language processing, XML, JSON, we use other people's code, which actually hide all of this stuff in there. There's a bunch of other things. There is literally very little in regular expressions, but it's experience that actually gets you there. By the way, this is the data I actually like to see this data. This is one record. Okay, and I can read this. I can read all of these records into R as a long data frame where this record becomes multiple rows, because what we have is a fixed part here. These are always the same. The first 4 elements are always the same format. And then there's a variable number of devices that we replicate. Okay, but one of the nice things you can do here, think about reading this data into R. It's highly non-rectangular. Okay, but I want to end up with a table and a nice data frame. One of the things you can actually notice is each element is separated by a semicolon. Yes. Within each element, the value is separated by an equal sign. Except for over here, the value is this triple of numbers, which are separated by commas. And the beautiful little trick is split each of these, this entire line, split it by semicolon, then go through each of the sub-elements and split it by equals, and then take each of the elements and split it by comma. Instead, split this line by all 3 characters with a character class. So what we just basically say is we say stir split. Okay, all of the lines, because we do this in vector, right? And we basically say this, comma, semicolon, comma, and the other one equals. And now what's going to happen is you're going to get all of these things separated out. And then you can just go and cherry pick the ones you actually want. And they're always going to be exactly the same place. And all of a sudden, this horrific thing has become really easy to read, okay, and arrange into a data frame. There's code on the repository to actually do this, but it's that magic bit on the right-hand side of this, that character count of just those 3 things. So if you think about this very differently, you can just do some incredible things. So 4 characters essentially has transformed the signal into 3 separate steps. Okay, and it just, oh my God, this thing just unravels. And this is the power of regular expressions. Pain in the butt, but very, very, very useful because there really is very little to learn. In the slides, the stuff I was writing down, the literals, the character classes, the while constant special characters, the quantifiers, you're done. Okay, that's all. It's basically 5 elements that you need to understand. And then just about 20, 30 years of experience will get you along. Okay, but you can, to get that experience, you can build up slow. Okay, but they're really, really powerful. And this is for cleaning data and for reading data. They just actually greatly simplify a lot of stuff. So, any questions?
This may be too specific, but can these principles be applied to some code-based languages?
To which?
Like Chinese, for example.
So this will all work if you use they will work on any character set as long as you're using the right characters. Okay, so you can type in literal characters in Chinese and it will match them in Chinese. Okay, so because any other language doesn't know about Chinese, it just knows about character sets, so no problem whatsoever. However, if you write down A through Z, and then so in other words, the alphabet, any character in the alphabet that you expect it to apply to Chinese, you're out of luck. But this is where if you come along with this alpha business here, this named character class, it'll say the language your computer is using is Chinese. You must mean me to use Chinese. Okay? And if you're using Mandarin or whatever it is, it'll switch to that based on what your computer's doing. And if your computer is using regular US English, okay, and you want to deal with Chinese characters, you change your computer. You just tell your computer for the next 3 commands, I would like you to use Chinese as your locale. So there's a sys.set locales, and you can switch over, and then everybody switches over to a different character set. Okay, and including, unfortunately, the error messages will come out in Chinese too. Okay, so get your code right first. Okay, any other questions? Yep.
Yeah, so like Matt, you mentioned, you kind of construct these huge regular expressions that are pretty arcane. Are there any tools for, like white space is obviously a bad idea, but for breaking these apart and simplifying them into maybe sub-functions, like better organization or structure to impose on regular expressions?
So the really simple way to do it is you can chain together regular expressions that say match this piece, match this piece, match this piece, and then you can basically put those all together. So there's a couple different ways. You can use graph which gives you a backological, and then if they're all true, but that doesn't necessarily say they're all referring together. You can chain. Duncan has some code in the example for programmatically creating really long regular expressions, but he's using R to basically put all the pieces together rather than you're sitting there typing every single piece.
But so one thing you can actually do is you can just write, we can actually go back to, you have this little bit. This is for the day of the month. Okay, day of month. Okay, you can have this, and then you have and then there's a separator, and then we have the month. Okay, so we have that month somehow, we have the year. So you could actually write this as a string, then write this as a string, then write this as a string. So you now have a vector of these 3 strings, okay? Okay, and then you can just do paste of this thing, that's called RX elements. So RXE, and you just basically say collapse equals quote dash here. Okay, and then so you have the elements, and then you're just pasting them together into one big string. And you can give these names so they're readable and all that sort of stuff. Now you're doing it all in R, but at the end of the day, you end up with what you want.
So like on a higher level, you're basically doing string manipulations on regular expressions, like
exactly
join.
Exactly, and there's good and bad ways, but you can't put in a space here, because now the space is going to be a character it's looking for, and you go, so they're very hard to read because every character means something. So you're not allowed to format these in special ways unless you're going to post-process them in this sort of manner. But the example that Matt was alluding to is we had January, we wrote out January, February, and all that sort of stuff. I didn't like that. I'm just like too lazy. So I actually have these as the month abbreviation. So I just paste them together with an or and stick it inside the parentheses, and I insert that. And that's fun. One thing about what Matt is saying about is this. So this seems like a good idea. It's not. Okay. What Matt was sort of saying is, it's obvious when you say it, I think. Okay. Let's go and look for the day of the month. So we take a string that looks like this. So, 09, 12, 10, 2008, something like that. If we look for this, we'll find it. Now, if we then go back, so we do grepl of this guy here, my pattern here, this guy. So we get a tree, okay? And then we come along and we grepl with another regular expression, okay? So this is for the month. Okay, on the same vector of x's. This will match too. Strangely, the same thing. Okay? So when we or these, or when we add these together, they will both match, but they're not matching consecutively. So this is the trouble. We actually have to do these simultaneously. You have to say match this, followed by that, followed by this.
Unless you don't care.
Unless you don't care.
Yeah, so the cases where I use that is where, does this string contain this phrase? And does it also contain some other phrase? And oh, by the way, does it also contain something else? But it doesn't matter what it is. I just want to know, is it somewhere in there?
But, and you could if you wanted to, but if you're going to make life a lot more complicated, you could say, instead of using grep, you can do gregexpr, or actually just regexpr, and you say, okay, find where it matched. Now, then go find where it matched this guy. Okay, and then see do they overlap. If they overlap, you got problems. If they don't, but then now oh God, your head's going to explode. All to actually make your code more readable. So this is probably the best approach, is just to actually put them down as elements and then glue them all together. But at least you can now. So this is easy enough. If you remember what we were doing here. So just to take this, because it's a very useful. It's a shrewd move to actually try to make these readable. Mm-hmm. If we sort of said if we actually name these as this is day of month equals this regular expression, month equals this expression, and year equals this expression, what I could actually do is I could paste these together with the dash. Now I could also take exactly this. Remember we made these much more general, so they didn't allow that 32. We made these very complicated. Okay, I want to reuse these. Well, I can now, now we were over into this guy here, where this is the day of the month. All I need to do is just twist this around. So I can now sort of subset this by, so that this is RXE. Give me number 2, then 1, then 3. Okay, and paste them, but instead of collapsing them with a dash, put a slash in here. And now I've got to reuse my code. Okay, and this is a very good idea. Okay, and if I wanted to, what I could do is I could do this, then this, and then paste the two of them together, okay, with an or in between, and say, now match either of those guys all in one go, rather than 2 separate goes. So programmatically manipulating these things is a really good idea, because otherwise your head will explode. Yeah, and reading them, one of the reasons we write Perl, the language Perl, some of us say this is execute only, you can't read it, and you can't write it. Okay? And it's primarily because they use a lot of regular expressions in head as well. They're just, you've got to be so pedantic as to how this thing is going to be. That's why this book is actually quite long. It's because it's like, no, let's think through what's going on. I like the idea.
Yeah, I like that perfect. Because especially for readability, you assume people are familiar with like string manipulations, and then they can kind of rock what's going on.
Yeah, hopefully, but I like the idea of just trying to get to make them readable, because otherwise they really are tricky. Yeah, because of that, if you put a new line in, just sort of bring that gets included. So, but if you then say, read this in as a string and remove all the new lines, you're going to remove the one you actually care about.
Yeah.
But not that one, and then also writing code, you actually manipulate the code more.
So do only the new lines at the end of the line.
It's a mess. Cool. Thank you very much. You're welcome, sir. I'm glad you're here. But you see, way too short on as well. Oh, yeah. I even